Hello, my name is Haibin Zhu. I'm a professor and the coordinator of the computer science program at Nipson University. And my title for this presentation is Computational Social Simulation with eCargo and RBC. RBC means Role-Based Collaboration. So here, the contents include role-based collaboration, the eCargo model, group role assignment, and how to conduct social simulation with eCargo. And I will present two case studies, and then I will give you a conclusion. So, what do we mean by role-based collaboration? Role-based collaboration is a methodology. Okay, it has been developed through standing on the shoulder of giants. It comes from object orientation, multi-agent systems, distributed systems, CSCW, computer-supported cooperative work, optimization, system dynamics, and Chinese culture and philosophy. So you will find it's a very abstract model and can be applied to many cases. So RBC is a computational methodology that mainly use roles as the key component to model and formalize problems in collaboration and complex systems. It is also a research methodology, and you can discover many different problems in related topic. So RBC is such a research topic. Okay, it includes many different items, like from what do you mean by distribution? Okay, if you set up roles, okay, how to assign roles to agents? Okay, so and it will discuss the cooperation, how the agents playing roles. Okay, so and we also talking about the role specifications, the right titles we have to make. And we discussed collectivism or individualism. Collectivism is called GRA, and individualism can be simulated by a revised GRA. Okay, we call the top one first for a role. Yeah. Also, we discussed dynamics. And RBC provided dynamic assignment. And also it involves multiplayer games, including role assignment, including multi-player games, and also combinatorics. So this is the process of RBC. Okay, we can see this is used by an administrator for a team. Okay, remember the administrator is out of the team, but standing out of the team and manage the team. So he can manage the role negotiation, agent evaluation, role assignment, and role playing, and he can manage also the re-evaluation, reassignment, role transfer, but he is not involved in role playing. That's an important case. So, and the role-based collaboration hopes to make collaboration easy or efficient. So that's the goal through modeling and algorithms. So. So that's okay. That's the case for teamwork. So eCargo hope to specify such kind of teamwork. Okay. So and we will What do we mean by eCargo? So eCargo includes classes, agents, roles, groups, and objects. And in fact, in the model, we also use other components like messages, initial states, and human users. So that means any kind of system, including complex system, including social systems, can be composed of classes, objects, agents, messages, okay, roles, environments, groups, and initial states, and human users. It was developed through object orientation. Yeah, object orientation mainly discuss about classes of objects. And agent-oriented programming or methodology, provide two more agents and groups, a group of agents, right? And for role-based collaboration, we provide two more components. It's called environments and roles. So based on roles and environments, we make the specification more representative. Okay, we can express more deep or wider concepts in social systems. This is the relationship among the major components. So you can see we have classes of objects, we have a group of agents, and also environment of roles. So that means environment is composed of a lot of roles. So here from eCargo, and if we view an agent, we view like that. Any agent at any time point, it must play a role. The role is composed of incoming messages and outgoing messages. This part is called service interface. This part is called request interface. Request interface means rights, and service interface means responsibilities. If you see an agent in the long term, it has many roles and play around him or her and the robots. So at one time, it playing one role. So including incoming messages and outgoing messages. So eCargo can explain what Shakespeare said. All the world is stage, and all the men and women are merely players, and they all have exits and entrances, and one man in his time plays many parts. So parts are roles. So the exits and entrances forms a group, and the players are agents. So the stage is the environment. Of course, an environment is composed of roles and classes of objects. So the nature of collaboration, specified by eCargo, we can see that it's a group of agents play different roles by sharing the environment that is composed of classes and objects, of course, roles. So that's we can see eCargo is a broad review, or a methodology to investigate the role-based collaboration, and again for the world, for the society, for the social systems. So that's the initiate. We started our research from 2002, and the first conference publication is in 2003, and then continue 2003 another conference publication, and then the journal paper, and then the journal paper. This one can be taken as a stepstone for the role-based collaboration and eCargo model. So the next step is the group rule assignment. Like in the process, group rule assignment is after role negotiation and after agent evaluation. So now suppose we have an agent evaluation have done, we can conduct group rule assignment. So here is, so this is what it is. We can see, and that's our simulation. We are doing use GRE to organize or guide a robot team. This is a robot team simulation. So now we are applied to real robot teams. This is robot team formation. Yeah, so this GRA, we have to clarify several symbols. And M is the number of agents, N is the number of rows, L is means each row, how many agents are required. Yeah, so the number of agents required for each row. Q means the evaluation matrix. Okay, for each agent, how good, how well it plays a role. Okay, so evaluation. For example, you learn mathematics is 90, you learn arts is okay 85, like that. Q. And T is assignment. Okay, that means which agent is assigned to which roles. So here we do not care about classes and objects. They are used in an environment. Okay, they can be used in agent evaluation. So this is an example for an Q matrix. Like say there are 6 agents and 4 rows. So this is the number. I use the number from 0 to 1 to express the, I call it qualification matrix. This is a qualifications. So, and based on these numbers and this format, and we can define what do we mean by workable rows and workable groups. So T is a matrix, right, belongs to 1 or 0. 1 means assigned, 0 means not. So that's, and L is how many agents are required. So row J is workable if on the column, all the ones add together larger or equal to LJ, yeah, the required number of agents. So group G is workable when all the rows are workable. Yeah, so, and this forms an optimization problem. Okay, so that means this is the sigma. Okay, we get all the sum, and like this one. Like here we have an L is 2, 1, 1, 2, and so choose this one. The result is here 1, here 1, here is 1, this one, and this one, and this one. So you will get 0.71 and 0.97 and 0.64 and 0.53 and 0.76 and 0.6, because here we need 2. Here we need 2, right? Here 1 and here 1. So this one is 0. Yeah. So this is the best assignment from what? From the team viewpoint. You know, not this one you find what, okay, what happens for this one? It is not assigned, right? Because this one, this agent is assigned to this one, this row. That's for the team's performance. This one is if you use exhaustive search, okay, it will take time, okay. So that's and okay, this one, if we remove L, you can say if anybody knows, okay, the original we call it general assignment. It's like that, you know. Yeah, that's general row assignment. So, and what's that? And here is 1. Here you will remove it, you know, 0, 1. Okay, so this is just equals to 1. That's general. Okay, so GRA, well, you know, that's M equals N. That's the original general assignment. So can be okay. Only you can have only 4 agents. So that's general, and that can be done by current matrix, but GRA is not. But we can adapt it to GRA. That's our solution. So the solution is okay. You know, exhaustive search is very complex, but if we adapt to current matrix, it can be done in OM3. M means the number of agents. So actually from GRA, and we developed many different steps of assignment, and we call it GRA CAR and GRA CCF. Means GRA CR means introduce conflicts, okay, and you know, this is GRA, okay, and this one is efficient row transfer. Row transfer can be done by row assignment. And then this avoid conflicts by GRA. by introduce a conflict matrix. That's agent conflict. We specify 1, and also, and we have this is called GMI. That means, okay, GRE, we assume that one agent can only be assigned with one role, but GMI, we assume that an agent can be assigned with more than one roles. So this is the GMI, we also call, and this is called GMI. Okay, these two is same problem but different solutions. And another one is, okay, cooperation, okay, not only conflicts but also cooperation. So this one we introduce we call it cooperation and conflict factors. We use -1 to 1 to mean this factor. Negative means conflicts, positive means cooperation. So we can do assignment to extend cooperation, avoid conflicts. That's called GRE-CCF. Also, we can use the balance of GRE, the group role assignment, balance the preferences of the manager. Remember, RBC has a manager. The manager may have different preferences for agents. We can balance that preference with the maximize of the group role assignment. So this is another one. So I present this one means I provide a set of tools for all the people who are involved in social simulation can use it. Yeah, this is maximize group performance with minimize budgets. And also we have another one is avoid critical members in a team by redundant assignments. So that means, what do we mean by critical? If this agent leaves the group, okay, nobody can replace him. Okay, so that means critical agents. So here we propose many different interesting solutions to give the least redundant. Okay, so for this group, if you require 5, I just provide 1 more, and to make everybody not critical agents. So now, yeah, because all these tools, so now we can start social simulation with the eCargo and related tools and algorithms and also the programs. So now, yeah, because we have such things, and components in eCargo, right? We have messages for communication, we have decision making for assignment, we have roles, we have the goal for maximize the team performance. We call it the team performance, actually this individual performance sum, the sum of the individual performance. Yeah, you can see simple. Yeah, it's simple, but you can justify by introduce more factors. And leadership is a special role in the group. And sharing, we use sharing the environment. And Q, for you can even think of Q is a social capital or part of a social capital. And also you can use roles to express trust and role players. That's what I think why eCargo can meet the requirement of social simulation, because we considered most of all the components in a society. This is the basic process, for using the eCargo. Okay, first one, you need to identify a problem. This problem may be a social problem. For example, 80-20, 20 problem, or Pareto improvement, for example. Okay, you clarify the requirements as roles, requirement, and supplies. Yeah, normally you will have requirements. We have supplies. So then you have 2 sides. We can do assignment. Okay. So now you can check if Q can be formed, or you can assume some way to compute it, and then you can do a group rule assignment, right? So if it cannot be obtained, you can investigate, propose a new way to evaluate this matrix. Even create a domain-oriented Q matrix. It's a good contribution. If you think that's enough, you can publish. Okay, after that, you can check the structures are sufficient. yeah, like the number of agents, number of rows, or the we call the row requirement for L, the the number. And then if not enough, okay, you can introduce a new one, and then you can specify and make it a new abstract problem, and then propose, and then if it's significant, you get a new publication, right? And also you can think of the social problem and assign the meanings to the Chicago structures like agent, role, group performance, or the assignment. Okay, and then you can introduce other structures to reflect some more social meanings. Yeah, and then you obtain the results, and then you can collect, you can make assumptions, random numbers, or you can collect real numbers, and then you can get the numbers, result numbers. Yeah, very interesting. So for example, how I compare between collectivism and individualism. I just use GRA to express collectivism, okay, because it's in the team's viewpoint, the maximum. And also use the, I call it BAR, best agent for a role. Okay, so that's one is called individualism. Okay, individualism means, okay, choose the best one. Everybody agree. Okay, it's fair, seems fair, right? So I compare that, statically compare, and also I introduce dynamic GRE. That means, okay, in a long period, we use many different type of reassignment. And then we can collect the whole performance. This performance become an area. Okay, so that means the total area for the assigned agents performance times the time, times the period for each segment, right? So that's in a collective area for dynamic one. So we can compare that. And in comparison, I also introduce an administrators, okay, factors. So that's very interesting. If you are interested, you can read this paper. You know, this is a comparison result. Yeah, if you are interested, you can check their paper. Another one is yeah, this is a paper published in IEEE transaction on computational social systems. And the second one simulation is why the Trump opposed globalization. I still use GRE, but this GRE I use investment. Okay, the investment for the big capital, you know, the giant capital in the world. Okay, and so I use that one as an agent. For roles, I use the country and industry, and yeah, that's country and industry. I extend to one line, so that means rows, and we revise the t can originally only 0, 1, 2, 0, 2, and a gamma. Okay, to maybe I say 5 means okay 500 million or billion. Okay, so or 500 million, right, like that. And also it's an interesting one. So the result means if you allow globalization, all the big capital or large capital, not large money in America are all invested out of America. So that's a big case. That's why I believe if Trump hopes to help America, they should stop that. That's the one thing. And this is published in IEEE transactions on computational social systems. So the conclusion is we use collaboration to check the social systems, and we provide many tools. So the Java programs have been published on the GitHub. Okay, so role-based collaboration has extended so many different branches, can also be applied in social simulation. And this is yes, you find what our RBC, we do research to do assignment to simplify the collaboration stuff. Coordination to interface, connection, communication, interaction, cooperation, and we do all outside to simplify, to decrease the task inside. That's a major case. So, and this is my book to be available in August, maybe a little postponed, maybe in September, but I hope that in August it will be printed out. Yeah, you're welcome to purchase this book. So, and if you search the reference, you can search my IEEE explorer.ieee.org. Okay, you can contact me. So any questions, you can send me email, or you can use the Harbor, GitHub, eCargo codes or Java codes related. Thank you.